We are Team Legacy, and I am Arham Kelkar. On behalf of Team Legacy, I am going to represent this UI and the website, which concludes the topic Disaster Management Alert and Risk Mitigation. So, first we have the authentication page where we enter the user's detail like full name, mobile number, email address, and especially location. With allowing alert and notification consent, after authentication, we come to the dashboard where we can see the pop-up ad of flood alert, which is of high risk in the recommended zone A and B and calls for the immediate evacuation. Below we can see that the satellite which are currently working and collecting the data, like here the Landsat 8, which is active, covering the altitude of 705 km with 98% of signal strength, which is good. And the last updated is 3 minutes ago. We also have the board for the risk assessment, which shows the flood risk, wind speed, and temperature, respectively, according to the specific or designated areas. We have small hyperlinks or boards for three of our models: satellite analysis, news analysis, and ground reports. We'll come back to that. First, we have the emergency safety guidelines, which shows the immediate action you should take after the disaster happens, the emergency kit you should have necessarily, and communication, the helpline or the emergency hotline you should have. Like here, we use 911 and stay informed by gathering the monitor weather alerts and evacuation orders. We also have the board for disaster awareness resources in which we have posted the blogs like flood preparedness guide, earthquake safety tips, and emergency kit essentials. Coming to our first model, satellite analysis. In this, we can see that the satellite analysis done on a specific contour or terrain, which shows that, or we can select it specifically, and the current satellite moving around that terrain, it shows here. Like Spot 7 is currently our satellite which fetching the data in real time and in real time sending us the data with orbit of 694 km, speed of 7.5 km per second, and coverage of 60 km of area with the signal strength, latency, data rate, which is 157 Mbps, which is good, and the last ping. And we also have the data of the next satellite, which will come under the terrain of the designated area, like Modis Terra, with 7 minutes of ETA and 30 meter of resolution. Below we have live analysis result, which shows the flood detected in the specific or monitored area, showing the confidence of 87%. The detection type is flood. It can also show the earthquake or the winds or landslide or storm, anything with the risk level. Here the risk level is high with affected area estimation of 2.8 kilometers square, and it is updated last 2 minutes ago. So we have to generate the alert. The alert status is active and the emergency response is dispatched to the designated or responsible authority and organization. We have also some pop-ups for safety recommendation. So anyone in the affected area uses our guidelines, or we can uh, generate a message to them to move to a higher ground to avoid flooded roads, or in emergency contact use this helpline number or the emergency kit. Coming to our next model, the live analysis model, in which we analyze the post on the social media and news portals and to verify that the specific uh, post or the news is valid or not, or it is containing the alert for the natural disasters or not. Like we have 247 total posts, in which 23 is high priority at 12 location with 78% accuracy. For example, a flood related post has been done by a user, and like that 100 more post has been updated so that it crosses the uh, limited threshold, like we have said 70 or 80, so it crosses the limited threshold, so it generates an alert and checks the news portals and the valid organization to check whether the specific zone is under control or affected or going to affect by the flood or not. Like we have the example of emergency alert, which shows the urgent flooding reported on mainstream to avoid the area and seek higher ground, with showing hashtag of food flood alert and emergency. We have sentiment analysis of the post and trending topics accordingly. Coming to our ground report. Our ground report shows the real-time on-ground analysis on which we can show the incident, where it is happening, what it is going right now, and which areas are affected by how many natural disaster. Like we are showing the flood is affected by three areas, fire is affected on two, storm and earthquake respectively, in which we have total of 47 reports, out of which 12 is urgent. We have to move accordingly and actively, rapidly we can say, to mitigate the risk, in which 18 is pending and 17 is resolved, thankfully. We have the report section to submit the report. Anyone can submit the report here to inform us about the report type, severity level, location, and description. So we can generate an emergency report to the authorized and responsible organizations. We have ground reports analysis here, which is active, which is investigating, and which is resolved. It shows us that how many affected areas is under control, having some resource management, etc., and which is going to affect, so we can implement the pre-disaster management here. Thank you. Talking about our models. Here we have our flood prediction model, the first model. Here we install the dependencies and libraries with with enhanced data loading and validation. We have completed the step. After that, we have secure feature engineering, in which we have extracted 13 features which is required for our prediction and decision making. After that, we have the balanced data splitting and optimized model training with model saving using XGBoost and XGB classifier. Further, we have enhanced model evaluation for best parameters, accuracy, precision recall, F1 score, etc. Here we have our confusion matrix, calibration curve, ROC curve, etc. with feature importance. We have used the dataset of around 50,000 with 93 parameters, and after advanced visualization, we have the risk probability distribution by class. We have generated comprehensive report, and by implementing Folium, we have deployed the world map showing the flood predicted areas respectively in the specific or designated zone according to the dataset. Like that, the flood prediction zone has separated respectively where it is affected, and it is the valid data which we are used. Coming to the Twitter model, the live analysis model, news analysis model. We have installed the required libraries. After installing, we have configuration, data structures, and enhanced processors to work on that. We have dataset class like using tokenizer, etc., model architecture, training functions, and prediction pipeline to analyze the news according to that. After finalizing our steps and deployment, we have implemented TensorFlow Keras models and TensorFlow Keras layers in this model. Coming to our last model, our CNN model, or we can say the satellite analysis. We have installed the required packages and libraries, or we can say the dependency. We have configured parameters, extract the data, directory structure, and process images. After completing in pouches, we have created enhanced data generators and custom F1 score metric with build enhanced model. With training configuration, we have completed the model training, and it is done in epochs like pouches. So it can be efficient and more reliable. With optimizing threshold and final evaluation, we can say that we have generated the general report of classification, precision, recall, F1 score, support, or you can see that here the confusion matrix, the precision recall, and the accuracy evaluation or loss evaluation. import TensorFlow SDF. We have implemented the TensorFlow here. And after completing it, that's our for our third and the last model. Thank you.